All right, good morning, astronomy class. Hope you guys are doing well. Um, we are going to be finishing up this chapter that we've been working on for several weeks at this point because I've been trying to make sure that we have enough notes to cover either coming back to school or not coming back to school at this point. We'll see. But good news is either way, there's only 5 weeks left, and for the seniors in this class, there's only this week plus 3 more left. So I encourage you to endure to the end and do your best. Okay, so we're going to pick up with named galaxies. We spent last week talking about galaxies, and I feel like you can't really, you can just barely see. There we go. You just barely see the words there, and we don't want that. Anyway, last week we talked about galaxies. So this week we're going to look at specifically named galaxies. And we're going to talk about 4 in particular. Now there are more than the 4 that I'm going to discuss, but we're going to look at these 4 because one of them we live in and the others are closer to us than any others, okay? So the Milky Way galaxy. This is the barred spiral galaxy that our solar system is found in. Okay, the Milky Way candy bar is actually named after the galaxy that we live in. We live in between the center and the outer edge of this galaxy. And the swath of light that we see when we look up at the night sky in the center of the galaxy is the center of the galaxy, is the center of the galaxy as seen from an outer arm. Okay. It's believed to be 100,000 light years across and about 10,000 light years thick. The galaxy is in constant motion, okay? It's always moving. Galaxies in general are in constant motion. They are typically expanding outward, reaching their fingers out to further regions. This motion, causes our solar system to travel at an average speed of 515,000 miles per hour. Now, you don't feel that. You don't even know that's happening. Just like you don't even realize that the earth is spinning while you stand on it, okay? But all of that happens while we walk day to day, while we sleep, eat, perform our daily functions. We are speeding through the Milky Way galaxy at 515,000 miles per hour. An enormous cloud of hot gas that surrounds the galaxy is also in constant motion, okay? So our galaxy is somewhat unique. It's not, this feature can be found in others, but with our galaxy, it's actually encased inside this ball of gas as well. The basic shape of the Milky Way galaxy is a large central bulge with 4 arms branching off from it, so pretty much a big circle in the center with 4 swirly arms coming off in different directions. It has 2 major arms and 2 minor arms, along with 2 smaller spurs. Now these spurs are little, they're little ejections, okay, off of the center bulge, but they don't reach far enough to be considered an arm, so they get shortened to a spur. They also look like a set of spurs would on cowboy boots. The Orion arm is one of these spurs. Our solar system is found in this spur, okay? So we actually rest in a spur which is located between a set of arms, okay? New stars are constantly formed in the arms of a galaxy, and this is because there's a lot of free gases, a lot of free dust in the Milky Way galaxy that are allowing new stars to be formed. The disk of the galaxy is found in its arms. The galactic bulge is the center of the galaxy. This is full of gas, dust, and stars. The bulge blocks us from seeing the majority of the stars in the galaxy. So think of all the stars that we can see in the night sky and just how overwhelming that is, right? That's only a small fraction of the stars in our galaxy, okay? There are hundreds of millions of billions of stars in our galaxy that we've never even seen while standing here on Earth because it's blocked by the bulge of our galaxy, all right? Now, Stop and think about that for a minute. Because when God made his promise to Abraham that his seed would be as the stars of heaven, and just think about all the stars that we can see and how magnificent that number is. Now take and add all the stars just in our own galaxy that we can't see, and let that sink in and settle for just how much God promised to Abraham. All right. A spherical halo surrounds our galaxy. This is composed of hot gas, old stars, and globular clusters. These compose about 2% of the halo, okay? Now, the halo is made of more than just these items. These items only make up about 2% of that, okay? It's believed that about 90% of the galaxy is made up of dark matter, with 8% being newer stars and our solar system. So they say our solar system and new stars make up about 8% of the galaxy, okay? So then you have that 8% and the 2% of the hot gas, old stars, and globular clusters. And then you take, and they believe that the galaxy is made up of 90% dark matter. And dark matter is something that's very interesting in science. It's a fairly new concept when it comes to astronomy. Now it's several decades old, the theory is, but it is relatively new as far as other theories in astronomy goes and other studies in astronomy goes. The Milky Way galaxy contains about 200 billion stars. It is made up of mostly red dwarf stars. Our galaxy is believed to be a young galaxy, okay? Which I find interesting, that even secular astronomy says that our galaxy is a young galaxy, especially when, as a creationist and as a Christian school, we take the stance and we teach that we are a young earth, okay? That God created us not much more than 6,000 to 7,000 years ago, all right? So the fact that our galaxy is believed to be a young galaxy, I feel like that just helps spur on that idea of a young earth. Oh, let me take a drink before I start another galaxy here. All right, the Andromeda Galaxy. The Andromeda Galaxy, it's also has a number letter abbreviation, or M31, okay? It is the closest large galaxy to the Milky Way, so it's our closest neighboring galaxy. Well, it's our closest neighboring large galaxy, okay? It can be seen from Earth by the unaided eye, which I think is really awesome. And it's just north of the constellation Andromeda. So if you find the constellation Andromeda in the night sky, look just north of that and you will be able to faintly see the Andromeda Galaxy. It is a spiral galaxy, which we talked about types of galaxies last week. So if you need to refresh your brain about what a spiral galaxy looks like, go back to your notes and refresh your brain there. But there are at least 2 spiral arms that compose this galaxy. There is also a ring of dust from one of its companion galaxies. Now, a companion galaxy is sort of like a sister galaxy, okay? It's not exactly a galaxy that can stand alone by itself, but there is enough of it there for it to be considered a companion to the Andromeda Galaxy. And it contains about 1 trillion stars, so that's even more stars than our Milky Way galaxy is said to have. There are 14 dwarf galaxies that surround the Andromeda Galaxy, so there are 14 smaller galaxies around the Andromeda Galaxy. 2 of these distort the spiral arms of the galaxy due to gravitational interactions between them, okay? Gravity between objects has the ability to distort shapes, especially in space where there's not much to hinder them, okay? We don't necessarily realize that as frequently here on Earth because we don't see it happen as frequently, but in space there is not much to hinder that happening, so it does occur fairly frequently. The composition of the galaxy, the core of the galaxy, we're talking about Andromeda here. The core of the galaxy consists of a double nucleus, and I think this is really cool. It has a double nucleus. This means that the nucleus is composed of a massive star cluster and at least one gigantic hidden black hole. Okay, so there is a star cluster and a black hole that work together to form this double nucleus. Okay. It's believed that Andromeda houses many black holes, including a binary black hole. And binary black holes are black holes in general. Okay, before I even get into binary black holes in general are a very intriguing concept to astronomers. They're still studying them. They're still learning a lot about them because the science on them is constantly changing. They are always learning something new about them. And the idea of a binary black hole, it's the idea of two black holes that either exist so closely together that they look as one, or there's also a theory out there that it's two black holes that circle each other. Okay, they revolve around each other. So I think they're pretty interesting. There is a large halo that surrounds the galaxy. It is believed to be expanding. That halo is believed to be reaching out, expanding. Like I said, the idea of galaxies expanding, reaching out their fingers, forming new stars with that expansion. Astronomers say that the Milky Way will one day collide with the Andromeda galaxy. The two galaxies are traveling towards each other at 70 meters per second. And that sounds really fast, but when you take into the account that they are millions of light years apart, or thousands of light years apart, excuse me, in space, it's not, we are not imminently doomed to crash into it, let's put it that way. The fact that there are 2.5 million light years away from one another, there you go, 2.5 million, I was wrong on the thousands, I apologize. This causes the speed of their travel to not be an issue for today. It is estimated that they will collide in 4 billion years, okay? And if you believe the Bible and you believe that Jesus is coming back someday, then you don't got to worry about it because everybody's going to be gone by that point. Everybody's going to be in heaven. Or, well, hell if they rejected Christ. Just some history on what we have observed about the galaxy. The Andromeda galaxy was first observed in 964, okay, 964 AD here, by a Persian astronomer, I'm not even going to try to butcher that. I'm sure one of you could say it so much better than I could, and I don't want to butcher it. Anyway, Al-Sufi, okay, he described it as a small cloud in his writings. In 1887, a man named Isaac Roberts took the first picture of this galaxy, and until the 1920s, it was actually assumed that it was part of our Milky Way galaxy, and when Hubble did a lot of work to actually prove that they were two separate galaxies. Hubble did a lot with astronomy. I would encourage you to look up his life, get some more knowledge on him. The Sombrero Galaxy. This is a much smaller galaxy than the Andromeda Galaxy and the Milky Way Galaxy. But the Sombrero Galaxy, or M104, is a barred spiral galaxy that's visible from Earth. It's located near the constellation Virgo. So if you find Virgo in the night sky, look to the, I'm trying to remember which direction, I believe it's to the right, and you'll be able to see this galaxy very faintly. Oh, excuse me. I promise I don't have coronavirus. Okay. Whew. The composition of this Sombrero Galaxy. Now, the galaxy has a bright nucleus and a large central bulge. It's approximately 2,000 globular clusters circle the nucleus, okay? So there's a dense population of stars around this nucleus. A thick dust lane surrounds the spirals, creating this sombrero look when viewed from the edge on that makes the galaxy famous, okay? Now, if you were to view the galaxy from the top, you are not going to notice this sombrero look created by these dust lanes, but if you view it from the side, it does look like a sombrero, hence the name Sombrero Galaxy. A massive black hole is found at the heart of the galaxy. It's believed that it could be the largest black hole at the heart of any galaxy. Okay. And the last galaxy we're going to talk about, M87. It's an elliptical galaxy that can be seen from Earth again. It's found inside the constellation Virgo. It has a jet extending from its central black hole, and there is no star formation or dust lanes, leading astronomers to believe that it was formed when two galaxies actually merged together, because there is no free dust, there is no new star formation. So because those things are lacking, they believe that it's actually a result of two galaxies coming together, and when they came together, it used up all of that free dust and free gases to not allow new star formation. All right. So that is it for this chapter on deep sky objects. Hopefully you've been keeping up with your notes. Hopefully you are working on your test project for this class for this week, well, last week and this week. That does need to be emailed to me by Friday, and I hope you all are doing well. I miss you guys, and I'm praying for you.